Hey Wesley, this is 4.2 Richardson extrapolation. So extrapolation, okay, we're trying to find n3h, which is an approximation for f prime of x naught. For the following, we're going to do 1c from the book, 4.2. Okay, let me write it down up here, 4.2. And it says, the question is f of x equals 2 to the x sine x, x naught is at 1.05, h is 0.4. Okay, so general things we need to know about it. So our complexity will be O of h squared when we calculate our n1s, which is n1h, h over 2, h over 4. h4 will use n1h, and this will be of complexity h to the 4, and this will be of complexity h to the 6, okay? And so we'll use two n1s to calculate this n2, and then these two again to calculate n2 of h over 2, and finally we'll use these two to calculate n3 of h. So our formulas are here to find n1 of h. n1 of h is actually f prime of, whatever number you're given, x naught, which is 1.05 here. And to calculate f prime of any number, it is that plus our h, that minus our h divided by 2h. And this is the formula to calculate subsequent, whatever n. So this you have to calculate using this formula. But after that, for these, you'll use this formula. So let's start. So at first, we are trying to calculate n1 of h, okay? But n1 of h is actually f prime of x naught, okay? So our x naught here is 1.05, f prime of that. And f prime of that formula is f of x naught plus h here is 0.4, minus f of x naught, which is 1.05 minus 0.4 over 2h. So 2, our h is 0.4. Okay, so f of 1.09 minus f of 1.01 over 0.8. So to find f of each number, let's see. F of x is theta x sine x, which will give me f of this. Okay, so this is actually 2 to the x sine x. And same for here, minus 2 to the 1.01 sine of 1.01 divided by 0.8. So if you put that in a calculator, you'll get 0.227443. So that is our n1 of h. Cool. Let's calculate n1 of h2, which is f prime of h over 2, which is f prime of what is 0.05 over 2 is 0.525, which is f of 0.5.
Level up to use that stack.
Sorry, it was an f prime of 1.05, same as here. But now we're doing it h over 2, okay? Instead of h, we're doing h over 2. So h over 2, our h is 1.05. Our h is 0.4. So our h over 2 is 0.2, right? So 0.2 f of this plus h is 0.2 minus f of 0.5 minus 0.2 over 2 times 0.2, which will be 0.4. So when you do that, it is f of 0.7 minus f of 0.3 over 0.4. Okay, and same thing, you'll do 2 to the 0.7 sine 0.7 minus 2 to the 0.3 sine 0.3 divided by 0.4, and you will get, so make sure to put your calculator in radians, otherwise I'll be messed up. Remember radians. Okay, 0.1706766. And 706,766. Actually, there's one more 6, 7. Cool. So now we have n1 h over 2. Similarly, now we'll calculate n1 h over 4. So here are h over 4. Instead of h, we have h over 4, which is 0.4, which is 0.1. Okay. So it'll be f of 0.5 plus 0.1 minus f of 0.5 minus 0.1 over 2 times 0.1, which is 0.2.
Yeah.
And finally, if you do substitute that function back, you alright. If you substitute that, you will get, let's see, you'll get 1.709986839. Pretty long, huh? In exam, we'll have 40-bit, accuracy, so we'll be fine. So now that I've found this, you see, I can use the formula to use these two to calculate n2 of h. So I'll use this formula up here to calculate my n2 of h, okay? n2 of h should be nj minus 1, my j is 2. So n1 of h over 2, it says, plus n1 of h over 2 minus n1 of h. Like here, we'll use these two over 4 to the j. What is our j? J is 2. 2 minus 1, 4 to 1 is 1 minus 1. So n1 h over 2 is 0.170676667. Okay. Plus n1 h over 2. Same thing, 0.170676667 minus, so the h and 1h over here, which is 0.2274443 over 3. So that will give, so this will give us 0.151754557. Cool. So that is our n2 of h. Don't forget, we are told to calculate, let's see, n3 of h. For that, we need n2 of h over 2. You see, use that by calculating these two, it says.
Sit down.
Because, to get here, we need these two. So if I follow the formula over here, it is n1 of h over 2. See, if it was h, it would be h over 2. So it's already h over 2, so it will be h over 2 over 2, which is h over 4. Okay, plus n1. This is h over 4, just like I said, minus. So see, instead of n1, because 2 minus 1, h, we have down here h over 2. So basically, you are replacing h over 2 and, h over 2, and instead of h, you are doing h over 2. And then 4 to the j minus 1. So 4 to the j minus 1, which is 2 minus 1, which is 1 minus 1. Cool. Which is the same as up here for the denominator, at least. So for that, you see, you have to calculate n1 of h over 4, which we had already done. Good. So I would have to do it again. So 1.7. Oh, this is not here. Okay. Only this divided by that. So 3.709963839. Okay. Plus 1.709986839 minus n1 of h over 2. Where is our n1 of h over 2? Which is this dude right here. 7. When I say radians, I'm saying all of this has to be calculated in radians. The sign up there. It's confusing. You might forget. So this is divided by 3. And this will give us 2.22309023. Great. So now we have both of these, which means this can finally give us N3 of H, which we are looking for. N3 of H. If I apply the formula right over here, it should give me N2H over 2. N2H over 2. It's okay, Jonathan. It doesn't bother me. H over 2 minus N2H over 4 to the H. So H here is 3. So 4, 3 minus 1, 8. 8 minus 1 is what? 7. 16 minus 1, which is 15. So N2 of H over 2 we found was 2.22309023 plus same thing, 2.22309023 minus, what is that? N2 of H we found was 0.151754557 over 15. So this will give me, and this will give me my answer, which is 2.36117925. And that is going to be my N3 of H. That is my Richardson's extrapolation, section 4.2. Let's see. Right over here. Great.